Hi, and thank you for joining me today. My name is Jim Armstrong with Snyk. I'm a product marketing manager here, and in today's session, what I want to take you through is Snyk Container and how we can use Snyk Container to build better containers, right? More secure and safer containers. We're going to walk through several things. One, we'll do a little bit of level setting, really focused on the security perspective of containers and some things that we need to think about as we think about securing containers, and specifically moving that responsibility over to developers and enabling them to fix containers. And we'll take a look at loads of demos as well, and how we can use Snyk Container to do this. And then finally, I want to put this all in the context of the actual application as well. The container is just one part of it, an implementation detail of the greater application. So I want to bring that perspective in here too. So just to kind of set the stage, right? We're not going to do a whole what's a container, what's a VM. We don't have time for that. Loads of good content on that if that's where you are in your journey. But generally speaking, a VM is built to last, right? It's built to last for a long time. There's a specialist generally, there's a virtualization specialist and an operating system specialist who knows all about the ins and outs of each and every VM and how to configure it and how to fix the operating system. And that's what they do. Containers have a very different mentality. They're built for speed, right? And they're not built to be patched and fixed. They're built to replace parts. If something breaks, you just replace it and you put a new one out there and get back out on the track as fast as possible. I think this car analogy works really well. It's not that either one of these cars is bad or necessarily better than the other in every way. Both cars are great for their use cases. But how you treat them, how you maintain them, what you do with them is very, very different. And it's a very different mentality. Very different people as well, right? There's a specialist who takes care of the luxury car, who knows all the ins and outs and details of that car. The race car, if the tire goes off, there's a person who knows how to replace that tire in 2 seconds, and that's done very quickly and almost automatic, right? And that's the idea of containers, is you have that sort of swappability and just easy replace and move on. It also has implications for security and containers, right? If I have a golden base image and that base image has a vulnerability, it doesn't mean that every container created from that base image has a vulnerability. They all started from the same place, but they may run for 3 or 4 years. I used to work for VMware and I had customers who would proudly show me their vCenter reports for VMs that hadn't been rebooted in an entire year. Right? As the longer and longer those things are out there, the more they become kind of individualized, right, and different. And so that's where that expertise is really required to maintain them over time and know exactly what that VM is used for. Containers, that mindset again is very different. If I have a base image and I build containers on top of that, then every container that has that base image, if it has a vulnerability, that vulnerability at some level exists inside that container. Right? And so it's very different. If the base image gets fixed, I need all those other containers to also get fixed and take in that fix for those vulnerabilities. So again, the whole process here is very different as well. And again, we're talking about a different person. It's a person who may not know a lot about operating system vulnerabilities and patching systems and all those other things. The developer's focus is on the code, right? Same thing with the types of information, specifically when it comes to container security. A report like this, which is a container security report, right, is not very useful. It's useful for determining whether it's a good container or bad. It's got a ton of vulnerabilities in there, so I can make that determination. But if I wanted to fix this thing and I wasn't an operating system expert and I wasn't a security expert, this probably would not be all that useful to me because I don't know where to start with this, right? I don't know what to fix. Specific to a container, I don't know what to do. The container, we don't think of it in this long list of vulnerabilities, and then I'm just going to apply a big patch set to it and it'll be fine. That's not how it gets fixed. I need to know whether it's something that I introduced to the container, right? In which case there's a very different process for fixing it versus something I inherited in my base image and how I'm going to go about fixing that. So different, depending on the answer to that very simple set of questions, right, my process for fixing things and securing that container can be quite different. So when we think about developer first container security, right, we take all of that into mind. The containers are very different. The people that we want to be responsible for securing these containers may not be the experts in operating systems and in patching things, right? They're experts in code and we want to get them back and focused on code. So we need to get the fix information to them as fast as possible. We want to be able to, give them this very simple process to follow, secure your code, build on a safe base image, secure the things that you add to the container. And then finally, again, with a container, right? Once we build it, we have to think about how it's configured, because again, that's usually up to a developer, whether you're running in Kubernetes or you're running just native containers or serverless or whatever the case may be. You want things to be configured to run securely as well. More importantly, too, we want to make sure that the information we provide is in the right places, right? An Excel spreadsheet or spreadsheet of any kind, right, is not necessarily a useful output for a developer. It needs to be in the places where they are and where they'll see them and where they can actually do something with that data as opposed to pulling them out of it. Again, we want to keep them focused on the things that are important to them and really important to our company overall, which is building better applications. So what we're going to look at when we go into the demos is really focused on this sort of middle set of things in terms of the process overall, the base images and how you prioritize what you fix. We'll look at several places where Snyk container can be used. So we'll look at local scanning locally, we'll look at CI, we'll look at registries, we'll look at Kubernetes. We're going to see all of those things with Snyk in the demos here. I'm not going to spend a lot of time on writing secure code because you're at SnykCon and there's loads of sessions you can go to about writing secure code. There's one use case I do want to point out though, which is what do you do if you don't have the source code, right? And you can't really use Snyk open source to fix the images yourself. So I do want to show you that real quick. You may get a container. Let's say, for instance, you have a third party you've outsourced some code work to, and they are giving you just a container back as their output. We can scan that container and detect the code inside of it. So we can look for those application vulnerabilities inside the container. If you've never seen Snyk open source before, this is essentially what Snyk open source does, right? It's scanning, it's finding these dependencies that are part of the open source frameworks that I'm using here. I've got Ruby and Node in this particular example. This example comes from Docker Hub. There's loads of other ways I can get projects in here. We're going to see several as I go through this. As far as registries go, I could use ECR, ACR, GCR, lots of others too. I can import things from code. We're going to see some of that. Kubernetes, we're going to see that as we go through here as well, the CLI and CI too. So those are all ways I can get things into this view, but this one happens to come from Docker Hub. So we've got the code detection there if you don't have the source code, right, and still want to know what's inside your containers. All right, let's focus on the actual containers themselves, right? How do we go about building on top of a safe base image and making that determination to begin with? Loads of base images out there you can choose from, right? Most people are starting with Docker official images. Red Hat's got some images. VMware through Bitnami has some images. Lots of places you could go to get images. Still not necessarily simple. If I go to Docker Hub, for instance, and look for a Ruby image, this blog example we're using is a Ruby application, by the way. If we go to there and look, there's almost 700 Ruby tags that exist in that Ruby namespace. So picking the right one for my particular use case isn't necessarily a simple thing to do. And then there's the day-to-day management. Maybe I do pick the right one for today, but tomorrow it gets updated. Or tomorrow there's a slightly newer version. Instead of Ruby 2, there's Ruby 2.1 or something, right? I don't know. Or that's maybe not a good example. But anyway, there's updates that will come. So all of that is part of this base image management, and we have to keep on top of it. But we need to pick a good base image to begin with. So let's flip back over here and see how we can do some of that. I'm going to start with the CLI. So here I've scanned, so we looked at the blog image in the UI. This is the same blog image. I'm scanning it locally here. So I've got the Snyk CLI tool. The command I used to scan this was the Snyk container test, right? I gave it the image name. And in this case, I added the Docker file to it. Now the Docker file gives us that base image resolution. It also does some other things when we get to the user layers that we'll look at here in a second. But because of that, we have, there's loads of vulnerabilities here, but what we're getting straight to the heart of is the fact that this is built on a Ruby 2.5.1 image. That image has a ton of vulnerabilities in it and a fair number of high severity vulnerabilities as well. It happens to be, if you dig into the details, an image that's not maintained anymore. And so it's going to have a bunch of vulnerabilities, and they're probably never going to be fixed in that particular image. But what we get from Snyk is alternatives, places I can go directly from this. Knowing that I started at Ruby 2.5.1, what are some alternatives I would have that could get me better results? So I could go to the Ruby 2 image. That'll cut down the number of vulnerabilities quite a bit. It's still a fairly big image, so still a fairly high number of vulnerabilities. I've got some alternatives here that are slimmer images. And so I've got a Ruby 2.5 Slim that gets me down to 54 and only 9 high severity images. So all of that information is available just by doing a Snyk container scan here locally. I can also see very similar results from the view here in the UI. So I've got this this image, right? Exact same image. What I did to get this here. In this case, that one you saw comes from Docker Hub. But if I wanted to have this image locally monitored and just send the results directly to Snyk, I could do a Snyk container monitor instead of Snyk container test. That will send the results over to Snyk. And what happens when we're monitoring then is every day we're going to update these results with new vulnerability information. So if there is something new that affects this particular container, we'll get an alert. I can get alerts via Slack, email, Jira, etc., right? But I can see those results here in Snyk. This is the one, in this case, that we've imported via that monitor command. It's a slightly different image, but you can see here this one was tested 17 hours ago. It's going to be tested once a day by default. I can configure that, of course, to be a little bit different. But the same sort of information is here. Again, it's a slightly different image, so the base image recommendations are a little bit different, but still in that Ruby family here, right? You can see here we've got a vulnerability, in fact, that is new. And so that's interesting. The other thing that you can do here, speaking of picking a better base image right from the start, right? So far we've looked at scanning actual containers, but we could actually scan the Docker file. So here I've imported a GitHub repo, right? And I have a Docker file in it. Lots of other code is in here as well. So we do a Snyk open source scan. We've got a Snyk infrastructure as code scan, but let's just look at the Docker file. And again, same sort of information. Again, what we're scanning here is a Docker file. So we don't have the full image. I can't give you all of the vulnerabilities that are going to be in this image because that's very time dependent on when this image gets built. But if you build this with Node 6 stretch, I can tell you that there will be 752 vulnerabilities that you start with. And that's not good. And in fact, Node 6 stretch is another old image that's not maintained anymore. And so we get recommendations to move to something that's a little more recent and a little better maintained here. And that comes straight from the Docker file. So we can find these things and detect these things even before we get to the point of building an image. Now, the next thing, if you're familiar with Snyk open source, you may be familiar with our ability to do fixed PRs. So if you have a code dependency file, for instance, and we can automatically fix some things for you, we give you the option to open a fixed PR. You can imagine a little button here, since this is a file that's coming from a Git repo and we can do things like fix PRs. You can imagine a little button here that would allow you to do that. And it might look something very similar to this, for instance. And so we just want to make this even easier, right? And automate this as much as possible to make, getting to that base image as fast and as pain-free as we possibly can. The other side of this equation is what if you don't have a Docker file at all? Lots of ways to build containers that don't use Docker engines and don't use Docker files, cloud native build packs, Github. Red Hat's got some open source tools like Podman and Builda. There's all kinds of tools out there for doing that. As long as you're producing an OCI compliant image at the end of the day, it doesn't really make a difference. We can still scan it with Snyk, and I've got that over here as well. You can see it in the screenshot, but I built this Java app. It's a Spring Boot app, so it's using cloud native build packs to build it. You can see the build output here, and it built this container for me. There is no, as you see in the listing here, there is no Docker file here, so I didn't use the Docker engine or Docker file to build it. Spring Boot handled this for me with cloud native build packs. Then I did a Snyk scan of that resulting container, and I get the same types of results that we saw before. So again, it doesn't really matter what tooling you use to build the container. we can still scan it as long as it's an OCI or Docker compliant image. All right, that's a lot of information on the base image. Let's talk about the other layers of the image, right? And how we go about prioritizing and fixing the issues that are there. And, you know, there's a lot of sort of thought that goes into, and it differs by organization in terms of how we prioritize things. But generally speaking, people want to look for, you know, obviously, what are the vulnerabilities in my environment? But let's start with the high severity vulnerabilities. Which of those have exploits available in the wild? Because those are things that we need to be very aware of and fix. And then of all that, which are the ones that are actually running in my production environment? That's critically important too. If it's sitting in a registry, maybe I don't care at all. Those are the things that we want to prioritize in terms of fixing. Other things you might want to think about: is there a fix available at all? Or is it a package I can take out of the container completely, even if it doesn't have a fix, right? Maybe I don't need it in the production environment. What is the production configuration? I know it's running there, but that doesn't necessarily mean it's open to attack depending on my production configuration. So all of those details can be important as well. And there's loads of other things you could add that might help you add some context around the vulnerability results, as opposed to just the raw security information. So let's take a little bit of a look at that inside the Snyk interface here. We can see, let's go back to our blog test. So we looked at the base image results. I can come in here and I can take out all the base image results. So in the UI, I can tell it to exclude the base image results. By the way, I could do the same thing in the CLI. Snyk container, if I show you, there's an exclude base image vulns option here. So when I do this test locally or in CI, and you'll see an example in CI here in a minute, I can exclude those vulnerabilities from showing up. It doesn't mean they're not there. I'm just ignoring them. And so I'm past that point. I've already picked a better base image. But what do I get here? I get the actual Docker file command. Again, I've matched up the Docker file. Remember that in sort of our early step, we added the Docker file to the scan. And so I've got the actual Docker file instruction that introduced this particular package to me. I also have the package name, which is somewhat useful, but I can track that back to how that package got installed in here. And I can do that in one of two ways, right? The Docker file instruction obviously tells me what line I put in the Docker file that got this thing here, but the dependency tree then tells me which of the things I installed is the culprit, right? And so I can see all that. In fact, if I want to see the full dependency tree, I can do that as well and look at the packages. And again, this is more of the context type things. Do I need apt in my image? Development, probably, I would say yes, you do, because you want to add things that will help you build and test your applications. In production, probably not, right? So you might take a slightly different view on whether these vulnerabilities are important if you know whether this is a development container or a production container. And you can see all the other packages here as well. These are all the packages that have vulnerabilities. You can get the full dependencies if you want. And again, another thing that you can do and see from the command line as well, there's a print deps. So if you wanted to see that same tree in the command line, you could very easily do that. Another piece that we said would be handy for prioritizing vulnerabilities is knowing whether this thing is running in production or not. And we happen to have our blog running in production. And it's running in a Kubernetes cluster. So I've got Snyk container set up in the cluster. And what it does is monitor for new workloads or changed workloads. And it looks for the containers underneath them and scans them and sends those results back to me here to view and act upon. But additional information comes in because we're running this in production. So I can see some of the configuration details from Kubernetes as well, which also helps feed the prioritization of these vulnerabilities, right? Because now I know it's running in production, but I also know the production configuration for that. So we go back to the container that's underneath this deployment. We can look and see what's there, and we can see that they're based on this particular scan, right? And based on what we detected from the configuration, we can change this. So there's over here on the right, you may have seen this bubble in some of the other screens. We have this priority score, and we can see additional context, right? So we know it's a high severity vulnerability, but things like, does it have a fix available? Does it have a mature exploit? Is it running in production? It is in this case. What's that production configuration look like, right? All of those things are also important for the context of knowing whether I should fix that or not, and that goes into this priority score. The other thing you can see here too is we have some attributes that are added to this particular application. So this is a high criticality application. It's in production, right? It's front end, external. You can add your own tags to this as well. All of these things add additional layers of context and meaning to the vulnerability results that we're seeing in Snyk. And in fact, when I'm back at this projects page, I might want to just focus on things that are of high criticality, that are external facing, right? And I can filter out and get down to just those applications that meet that criteria. And again, that might change my policy on how I look at vulnerabilities in those different environments. Now, one of the other things that we have the ability to do is do these same sorts of scans from CI. And I've done several of these already, so you don't have to sit and watch it. And we'll take a look at one here. It's very similar, right? There's no major changes to the output and the types of information that you'll see in the CI scans. In this case, what I've done, just to show a slightly different view, is I filtered some of these. So I'm only showing vulnerabilities that are a medium or high severity here, and I've excluded all of the base image vulnerabilities. And we talked about how we could do that at the CLI before, and I can do that as part of my CI process too. So I've vastly cut down on the number of things that are going to show up here, and I have that same sort of detail that shows up in this scan report too. The other thing I've done here, on top of that, I could, if I wanted to, fail this build, based on the fact that there are vulnerabilities in here and the threshold and those sorts of things. I haven't done that here. I've allowed the build to continue. And I've also sent these results in for Snyk monitoring. So if I go back over here one more time, I can see this image that's been sent back to Snyk. And again, we'll test this every day and see if there aren't any new vulnerabilities that do appear in this, tomorrow and the day after, as long as it's here and being monitored by Snyk. I talked about CI. We can work with just about any CI tools that you might have. I do want to put a shout out for GitHub because this is fairly new for us. GitHub just released their GitHub code scanning a couple weeks back, and Snyk can work with that as well. Again, the whole idea here is taking those results and putting them in the place where a developer will see them and be able to do something with them. And that's what we have with this GitHub integration. So we're really excited about that. I know loads of people use GitHub and like the GitHub security tab for looking at those results, so you can get your Snyk container results inside of GitHub. If you are interested, so we're getting close to the end here. I just want to put a few shouts out there. If you're interested more in the patterns here, right? Talked a lot about the technology. We think about people, process, and technology. Focus a lot on the technology in this session. If you're interested more in the people and process side of things, I encourage you to go see Gareth's Rush Growth session, which is all about these patterns for base image management and how can you make that whole thing as efficient as possible, particularly when you have multiple teams that are involved in managing your images. The other side of this is managing the configuration. We didn't talk a whole lot about that. Again, there's a whole session on that I would encourage you to go see from Ben LaPlanche. If you remember when we looked at the Git import, we had a deployment YAML and some Terraform files in there. That's Snyk infrastructure as code. So I don't know how to fix that Kubernetes stuff without going and reading Kubernetes docs every single time. But Snyk infrastructure as code shows me exactly what to do, so I can make those changes much faster. So if you're interested in that, go see. I encourage you to go see that session. And if you want to see real live people who are not Snyk employees, who are using Snyk container in their environment, there's some great customer sessions as well. So this lighting, the flare, is being put on by folks at Red Ventures. We have Rally Health is putting on a session as well. So I encourage you to go see that. Hopefully this was helpful. Again, part of it is process, right? And what is the right flow for sort of fixing things from a developer first perspective. Part of it though is the technology as well. And hopefully you see how Snyk kind of flips that security process around to make this very friendly for developers to use in the places where they work. I do want to thank you for listening. If you do want to play around with some of the example apps that I have, you can get them from this GitHub repo. Feel free to reach out to me at any time. Again, I look forward to chatting with you, and I hope you enjoy the rest of Snyk. SnykCon, thank you.